Welcome to Innovation Pulse, your quick, no-nonsense update on the latest in AI. First, we will cover the latest news. OpenAI's GPT-5 is set to launch, Midjourney introduces AI video generation, Amazon boosts AI infrastructure, and Google expands its Gemini AI model family. After this, we'll dive deep into Sam Altman's vision of a gentle singularity and its transformative promise for our future. Stay tuned. OpenAI CEO Sam Altman announced that GPT-5 is expected to launch this summer, offering significant improvements over GPT-4. Though a specific release date wasn't disclosed, early testers describe GPT-5 as a major upgrade. OpenAI's revenue heavily relies on enterprise customers purchasing enhanced versions of ChatGPT, and GPT-5 aims to boost this trend. Altman mentioned the possible introduction of ads on ChatGPT, noting the importance of maintaining user trust by not altering the model's output based on ad payments. Instead, ads might appear externally, such as in sidebars. OpenAI is also facing legal challenges, including a court order to retain all ChatGPT output log data amid a copyright case with the New York Times. Altman criticized the Times' request, emphasizing the importance of privacy in AI use. Midjourney, a leading AI image generation startup, has launched its AI video generation model, V1. This model allows users to upload an image to generate 4 5-second videos. Available through Discord, V1 competes with models from OpenAI, Runway, Adobe, and Google. Midjourney aims to create AI models for real-time simulations, extending beyond simple video generation. The launch follows a lawsuit by Disney and Universal, alleging copyright infringements on their characters. Midjourney faces criticism over the potential impact of AI tools on creative industries. The service's pricing starts at $10 per month, with higher tiers offering unlimited video generation in slower modes. Users can control video outputs with custom settings, extending video length up to 21 seconds. Initial demos of V1 show its unique style, though its competitive standing remains uncertain. For now, let's focus on AWS's AI infrastructure advancements. Amazon Web Services is updating its Graviton 4 chip to feature 600 gigabits per second of network bandwidth, which they claim is the highest in the public cloud. AWS's Graviton 4, developed by Annapurna Labs in Texas, is central to Amazon's strategy to challenge established chip makers like Intel, AMD, and NVIDIA. At the AWS re:Invent 2024 conference, they unveiled Project Rainier, an AI supercomputer for Anthropic, and invested $8 billion in the startup. AWS aims to reduce AI training costs by offering an alternative to NVIDIA's expensive GPUs. Their Trainium 2 chips power Project Rainier, with over 500,000 in use. While NVIDIA's Blackwell outperforms Trainium 2, AWS claims better cost performance. The upcoming Trainium 3 will double performance and save 50% more energy. AWS's growing ambition in AI infrastructure raises questions about its potential market share against NVIDIA. Amazon CEO Andy Jassy announced plans to reduce the corporate workforce as the company integrates more generative AI tools. Jassy stated that AI will lead to fewer traditional roles but create new job types. Employees are encouraged to learn AI tools to enhance productivity with smaller teams. Since 2022, Amazon has laid off over 27,000 employees and continued cuts this year, including 200 in North America stores and 100 in the devices unit. As of March, Amazon employed 1,560,000 globally, including temporary warehouse staff and contractors. Generative AI is used widely, including in inventory and warehouse management. Similar shifts are seen in other companies like Shopify and Klarna due to AI. Jassy emphasized AI's role in saving costs and transforming industries, noting its rapid advancement as a significant technological shift. Google is expanding its Gemini AI model family with the highly anticipated release of Gemini 2.5 Pro, now available for developers to build on. After months of testing, this model is leaving preview, showing significant improvements over previous versions. Google also introduces the cost-effective Gemini 2.5 Pro Flash-Lite, currently in preview, which allows developers to manage high-volume AI tasks at a lower cost. Though Flash-Lite is less capable than 2.5 Flash and unlikely to reach the general app, it offers a budget-friendly option for specific workloads. Both models are now integrated into Google Search, using the most suitable model for each query. Gemini 2.5 Pro and Flash models are now stable in Google AI Studio and Vertex AI. Free users have limited access, while paying users enjoy higher access levels. These updates position Google competitively against OpenAI's GPT models. And now, pivot our discussion towards the main AI topic. Today, we're going to explore one of the most fascinating and potentially transformative periods in human history by diving deep into Sam Altman's recent blog post titled The Gentle Singularity. As the CEO of OpenAI, Altman offers a unique insider's perspective on how artificial intelligence is already fundamentally changing our world, his timeline for even more dramatic developments ahead, and what life might look like as we transition towards superintelligence. His concept of the gentle singularity suggests we're not heading toward a sudden, shocking transformation, but rather experiencing a gradual yet profound shift that's already underway. We'll examine Altman's arguments about how current AI systems are already outperforming humans in many domains, explore his specific predictions for the next few years, including autonomous agents and breakthrough scientific discoveries, and consider his vision for how society might adapt to a world where intelligence and energy become abundant resources.
Thanks for that comprehensive introduction, Alex. I'm excited to dive into Sam Altman's thinking here because I believe his perspective from leading OpenAI gives us unique insights into something truly unprecedented that we're living through, even if it doesn't always feel that way day to day. Could you start with your first question?
In his blog post, Altman mentioned we're past the event horizon and the takeoff has started. Can you explain what he means by that?
When I say we're past the event horizon, I'm referring to the point where the development of artificial superintelligence has become inevitable. We've crossed a threshold where the momentum is now unstoppable. The takeoff has started means we're already in the early phases of exponential AI development, even though it might not feel as dramatic as science fiction led us to expect. We don't see robots walking the streets or everyone talking to AI constantly. People still die of diseases, space travel remains difficult, and many mysteries about the universe persist. However, despite the seemingly normal surface, we've recently built systems that genuinely surpass human capabilities in numerous domains, and significantly amplify human productivity for those who use them. The hardest scientific insights that brought us systems like GPT-4 and O3 are behind us now, and these breakthroughs will carry us much further than most people realize. It's like we've already lit the fuse. The explosion is coming, but it's happening in a more gradual, manageable way than the dramatic singularity scenarios often depicted.
That's a fascinating perspective on our current moment. You also mentioned that ChatGPT is already more powerful than any human who has ever lived. How should we understand that claim?
This might sound like hyperbole, but consider the scale and impact. Hundreds of millions of people rely on ChatGPT every single day for increasingly important tasks, from writing and coding to research and problem solving. When you have that level of reach and utility, even a small new capability can create enormously positive impacts across society. Think about it. No individual human in history has ever been able to simultaneously assist hundreds of millions of people with complex cognitive tasks. But this scale also means the stakes are incredibly high. A small misalignment in the system, when multiplied across hundreds of millions of users, can cause tremendous negative impact. This is why the power comparison makes sense. It's not just about raw intelligence, but about the breadth of influence and the potential for both positive and negative effects at a scale no single human has ever achieved. The responsibility that comes with building and deploying these systems is correspondingly massive.
That scale is mind-boggling. Looking ahead, you have some specific predictions for the coming years. What should we expect in 2025, 2026, and 2027?
The timeline is quite aggressive, but I believe realistic based on current progress. 2025 has already brought us agents that can perform real cognitive work. We're seeing AI systems that can write computer code in ways that fundamentally change how software development works. This isn't just about code completion anymore. These systems can understand complex requirements and implement sophisticated solutions. 2026 will likely see the arrival of systems capable of figuring out novel insights, essentially AI systems that can make genuine scientific discoveries and breakthrough innovations, rather than just recombining existing knowledge. Then, 2027 may bring us robots that can perform meaningful tasks in the physical world, bridging the gap between digital intelligence and real-world manipulation. Each of these represents a major leap in AI capabilities, and the acceleration between these milestones shows how quickly things are moving once you're on the exponential curve.
Those timelines suggest rapid change. How do you think this will affect human creativity and expertise?
I think we'll see a democratization of creation alongside a continued premium on expertise. Many more people will be able to create software and art using AI tools, which is genuinely exciting. Imagine someone with a great idea for an app being able to build it themselves, or an artist exploring mediums they never had the technical skills to approach before. The world has an enormous appetite for both software and art, so this increased creative capacity should be welcomed. However, experts who embrace these new tools will likely remain much more effective than novices, just as we see in other fields where technology has been democratized. A professional photographer with access to digital tools and AI enhancement will still produce superior work compared to someone just starting out with the same technology. The key is adaptation. Those who learn to work with AI rather than against it will see dramatic improvements in their capabilities and output.
You paint a picture of dramatic productivity gains. What might individual capability look like by 2030?
The transformation in individual productivity by 2030 will be striking. A single person will be able to accomplish vastly more than they could in 2020, and many people will figure out how to benefit tremendously from this shift. We're already seeing scientists report being 2 or 3 times more productive than before AI, and that's just the beginning of this trend. However, I want to emphasize that in the most important ways, the 2030s may not feel wildly different from today. People will still love their families, express creativity, play games, and swim in lakes. The fundamental human experiences that matter most will remain. But in still very important ways, the decade will be unlike anything that's come before, as we discover how far beyond human-level intelligence we can push these systems and what that means for our capabilities as individuals and as a society.
You mentioned intelligence and energy becoming abundant. Can you elaborate on what that means for human progress?
Intelligence and energy, ideas and the ability to make ideas happen, have been the fundamental limiters on human progress throughout history. In the 2030s, both are going to become wildly abundant. With good governance, abundant intelligence and energy theoretically allow us to have anything else we might want or need. We're already living with incredible digital intelligence, and after some initial shock, most people have adapted remarkably well. This illustrates a pattern I call how the singularity actually unfolds. Wonders become routine, and then become table stakes. We quickly go from being amazed that AI can generate a beautiful paragraph to wondering when it can write a complete novel, or from marveling at medical diagnoses to expecting AI to develop the actual cures. This is the general nature of the singularity. Each breakthrough becomes normalized, creating space for us to imagine and expect even greater capabilities.
That pattern of escalating expectations is really interesting. You also talk about recursive self-improvement. How is that already happening?
We're seeing what I'd call a larval version of recursive self-improvement right now. The AI tools we've already built are helping us find further scientific insights and create better AI systems. While this isn't the same as an AI system completely autonomously updating its own code, it's a meaningful step in that direction. Advanced AI is particularly interesting because we can use it to accelerate AI research itself, potentially doing a decade's worth of research in a year or even a month. There are also other self-reinforcing loops already in motion. The economic value creation from AI has started a flywheel of compounding infrastructure build-out to run increasingly powerful AI systems. We're not far from robots that can build other robots and data centers that can essentially build other data centers. If we make the first million humanoid robots through traditional manufacturing, but then those robots can operate entire supply chains, mining, refining, transportation, manufacturing, to build more robots and chip fabrication facilities, the rate of progress becomes fundamentally different.
That automation cascade is fascinating. What does this mean for the cost of intelligence itself?
As data center production becomes automated, the cost of intelligence should eventually converge to near the cost of electricity. This is a profound shift. Intelligence becoming essentially a utility, like electricity or water. To put current costs in perspective, the average ChatGPT query uses about 0.34 watt-hours of energy, roughly what an oven would use in just over 1 second, or what a high-efficiency light bulb would use in a couple of minutes. The query also uses about 0.0085 gallons of water, roughly 1/15 of a teaspoon. These numbers help illustrate how efficient these systems already are, and as automation reduces the cost of the infrastructure itself, we're heading toward what you might call intelligence too cheap to meter. This abundance will fundamentally change what's possible for individuals and organizations when cognitive work becomes nearly free.
With such rapid change, how do you expect society and employment to adapt?
History suggests we're remarkably adaptable. The rate of technological progress will keep accelerating, but people have consistently shown they can adapt to almost anything. There will definitely be challenging aspects. Whole classes of jobs will disappear, but the world will be getting so much richer so quickly that we'll be able to seriously consider new policy ideas that were never feasible before. I don't think we'll adopt a completely new social contract all at once, but when we look back in a few decades, the gradual changes will have amounted to something transformative. Just as job markets evolved after the Industrial Revolution, we'll figure out new things to do and new things to want, and we'll assimilate these new tools quickly. A subsistence farmer from 1,000 years ago would look at many current jobs and consider them fake, just games to entertain ourselves, since we have abundant food and unimaginable luxuries. I hope people 1,000 years from now will look at future jobs the same way, while those jobs feel incredibly important and satisfying to the people doing them.
Looking further ahead, what kinds of breakthroughs might we see by 2035?
The rate of new discoveries will be immense, and it's genuinely hard to imagine what we'll have achieved by 2035. We might see progressions like solving high-energy physics one year, then beginning serious space colonization the next, or major materials science breakthroughs, followed immediately by true, high-bandwidth brain-computer interfaces. Many people will choose to live their lives much the same way they do today, but some will probably decide to plug in more directly. This probably sounds overwhelming when we try to wrap our heads around it from today's perspective, but living through it will likely feel impressive, yet manageable. The singularity happens bit by bit, and the merge happens slowly from a relativistic perspective. We're climbing the long arc of exponential technological progress. It always looks vertical when looking forward and flat when looking backward, but it's actually one smooth curve. Think back to 2020 and what it would have sounded like to have something close to AGI by 2025 versus how the last 5 years have actually felt to live through.
That's a helpful perspective on managing the psychological impact. What are the main challenges we need to address?
There are serious challenges alongside these huge upsides. We absolutely need to solve the safety issues, both technically and societally. The alignment problem is crucial. We need to robustly guarantee that AI systems learn and act toward what we collectively really want over the long term. Social media feeds are actually a perfect example of misaligned AI. The algorithms are incredible at understanding your short-term preferences and getting you to keep scrolling. but they do this by exploiting something in your brain that overrides your long-term preferences. After solving alignment, we need to focus on making superintelligence cheap, widely available, and not overly concentrated with any person, company, or country. Society is resilient, creative, and adapts quickly, but we need to harness collective will and wisdom. While we'll make mistakes, and some things will go wrong, we can learn and adapt quickly if we give users freedom within broad bounds that society decides on. The sooner the world starts having conversations about what these bounds are and how we define collective alignment, the better.
You describe this as building a brain for the world. What does that mean practically?
We're essentially creating a collective intelligence system that will be extremely personalized and easy for everyone to use. In this future, we'll primarily be limited by good ideas rather than by the ability to execute them. For a long time, technical people in the startup industry have made fun of idea guys, people who had concepts but needed teams to build them. It looks like they're about to have their moment because the gap between having an idea and being able to implement it is shrinking dramatically. This brain for the world will be accessible to everyone, highly customizable to individual needs, and capable of turning thoughts into reality with unprecedented speed and efficiency. The democratization of capability this represents is profound. Imagine a world where having a good idea is truly the main barrier to making positive change, rather than needing specialized technical skills, large teams, or significant capital investment.
Finally, how confident are you in this timeline and vision?
I recognize this may sound crazy, but consider that if we had told you in 2020 where we'd be today with AI capabilities, it probably would have sounded even more outlandish than our current predictions about 2030. The path ahead is increasingly well lit, and the dark areas are receding fast. Most of the fundamental scientific insights are behind us now. We're building toward intelligence too cheap to meter, and that's well within grasp. The feeling isn't one of uncertainty about whether this will happen, but rather gratitude for being able to participate in this transformation. The goal now is to scale smoothly, exponentially, and uneventfully through superintelligence, making this transition as beneficial and manageable as possible for everyone involved.
Yakov, thank you for walking us through this remarkable vision of our technological future. This has been a fascinating exploration of how we might navigate the gentle singularity ahead.
Thank you, Alex. These are the kinds of conversations we need to be having as a society as we move through this transition together.
That's a wrap for today's podcast. We've explored the exciting advancements in AI with OpenAI's upcoming GPT-5 launch, Midjourney's new video model, Amazon's AI-driven transformations, and Google's Gemini updates, alongside Sam Altman's vision for a future shaped by superintelligence and democratized creativity. Don't forget to like, subscribe, and share this episode with your friends and colleagues so they can also stay updated on the latest news and gain powerful insights. Stay tuned for more updates.